Apologies for the stream yesterday. If you were watching, had some technical difficulties that have been worked out. But FYI, this is episode 16A in the series, which is the one you're watching, which is Swift and SwiftUI Learnalong. And so this stream here, this episode 16A, is a full replacement of episode 16. Now, we will just eventually just go delete episode 16, but just so there's no confusion. So if you happen to see both and you come across it, don't get confused. 16A is a full replacement of 16, so you can just watch this one. But yeah, myself or Jared will get out there and delete those soon. Anyway, now we'll try to go a little longer today because we didn't get to do it yesterday. And we're just going to start over, like I said. So full replacement. Yeah. Easy enough to follow. Okay, so let's just jump right into it since we are in time debt, as the made-up saying goes. Okay. Closure, expression, syntax. Wait, now is this where we actually started? Let's see. No, we started here. Closure. Yeah, okay. So technically I should just come back here. So we'll do that. Okay. Closures. Chapter 13. Closures. Closures are discrete bundles of functionality that can be used in your application to accomplish specific tasks. Functions, which you learned about in the last chapter, are a special case of closures. You can think of a function as a named closure. Ah, dang. I wonder if the mic picked that up. Oh, my neck just popped so good. Okay, because functions are technically closures, Swift programmers sometimes use the two words interchangeably, much like parameters and arguments, despite the subtle distinction. In Chapter 12, you worked primarily with global and nested functions. Global functions are not defined on any specific type, and for this reason, they are also called free functions. So I meant to ask the Oracle question last time, so I'm going to do that real quick. So I just want to understand what I was trying to get ChatGPT to help me with the presentation, and it's just funny yet again that people think these things are going to take your job. If ChatGPT can supplement your entire presence in the process of making a presentation, then it probably could have just been an email, that kind of a thing. That's how I feel about it. But okay, so global functions, yeah. In the Swift Lang context, is print an example of a global function. Okay. So, okay, that's the accessible from anywhere. Okay. I guess they're about to tell us, but that's really cool because I'm starting to think I just kind of had the initial wrong impression of Swift as a language in general, which I admit, I didn't, until I got the itch, I never really even, I was aware of it only because of, I'm sure you guys, if you're watching this, you probably have heard of Fireship, the YouTube channel, /dude, Jeff or whatever. But yeah, if you don't know who that is, look up, go to YouTube, type in your favorite programming language, hit spacebar, and then type in 100 seconds. So like closure in 100 seconds. And more than likely he's covered your language or whatever one you want to look at. They're great videos. And by the way, I am a former customer of his in terms of his actual website. So if you go to Fireship.io, he offers courses as well. And I swear we'll get started, but just as a quick aside, what's great about those courses is I think that's probably the best money you could spend on a course if you're looking for an overview. I wouldn't expect too much of a deep dive unless the course explicitly states, you're going to build a very specific thing that's applicable to you. But in the grand scheme, overviews can still be useful. And so I think if you're curious and you want a deeper dive than, say, what a demo on YouTube would do, like let's say you're testing out Astro or something, some new framework, and you want to go and find out a little bit more about it, more so than the surface level marketing is giving you, but not so much, like not so deep to the point where you want to build an MVP with it just to learn what it's capable of. His courses are great for that, and it's pretty cheap. I think you can buy them individually, so maybe $10 or something like that. So yeah, it's a steal. Anyway, go check out his stuff if you haven't. If you need some quick hitter type courses, those are great, and great YouTube channel just for general entertainment and learning if you like to nerd out. Okay, now let's go back to it. So closures differ from functions in that they have a more compact and lightweight syntax. They allow you to write a function-like construct without having to give it a name and a full function declaration. Yep. This makes closures easy to pass around in function arguments and returns. Okay. So this itself is a closure. Or no. This is the closure. Yeah. All right, let's create a new macOS Playground. We did that already, so we already have it up. So let's just read through to get caught up. Closure syntax. Imagine that you are a community organizer managing a number of organizations. You want to keep track of how many volunteers there are for each organization and have created an array for this task. Yeah. So that's line 3 here. And that's what we have. You enter the number of volunteers for each organization as they were provided to you. This means that the array is completely disorganized. It would be better if your array of volunteers were sorted from lowest to highest. Yep. Good news. Swift provides a method called sorted by here, that allows you to sort an instance of array based on criteria you specify. We have mentioned methods before, but never explained the terminology. A function defined on a type, the way sorted by is defined on array, is also called a method. More on this topic. Okay, sorted by takes one argument, a closure that describes how the sorting should be done. Hence this dilly. Okay. The two arguments are compared, and the return value indicates whether the first argument should be sorted before the second argument. Yeah. So it just iterates over this. Compares 1 to 3, 1 to 40. Or I guess it'd have to compare all of them. One way or the other it does it, because we know that because it works. But so if we run, or not run, but that's what this is. So in I less than j. So it's just comparing each. And then, where do we go? Two arguments. Yeah. In the closure you pass to sorted by, you use the less than operator in the comparison if you would like the elements in the array to be sorted in ascending fashion. And that was kind of the thing I don't want to say get stuck on, but I guess, well, I'm not going to do it again. We'll just take it at face value for now and then talk about it during the challenge. That's probably a better way to do it. So for now, we just take at face value that if we want ascending order, we use less than operator. And use greater than in the comparison if you would like the elements to be sorted in a descending fashion. Like the addition operator, the less than and greater than operators are available for use with many, but not all Swift types. You will learn more about these operators and how to make them available to your custom types as well in Chapter 25. Because your array of volunteer counts is filled with integers, the function type for sorted by will look like a tuple with two arrays, and then return type of a Boolean value. Oh wait, that's the entire. Wait, because your array of volunteer counts is filled with integers, the function type for sorted by. Oh, that's the function. Okay, right. We learned about that. Okay. Oh, weird. Yeah, yeah. You know, this kind of looks like OCaml. So this is, I see. So these are the weird. These are the parameters. Oh, I'm looking at it wrong. Okay, I guess it's easier to look at here because this is the exact same thing, but yeah, okay. Well, no, that's not the same. What am I looking at? There's an extra. Oh, the return array. That's why I don't see it. Okay, so the full function type is this. Okay. So these are the, not that parentheses, but yeah. So the first tuple here, integer, integer, returns a Boolean. But that's all a function inside. So that is the argument itself, which is what they just explained. And it returns an array of integers. Okay. As you saw in chapter 12, function types begin with the parameters enclosed in parentheses. In this case, the single parameter is a closure. Yeah, that's why I get thrown off. Represented by its own function type. Okay, so this is just that without the return type. That's why it looks a little bit different. But that's the same function type. Oh, duh, because that's, yeah, there's your return. Or the array of integers, because we're making a new one. Based off the sorting here. Okay. I'm catching up. Alright, so then... okay, so in this case, the single parameter is a closure. Is a closure represented by its own function type. So in other words, sorted by is a method that takes a closure. There you go. That closure in turn takes two values to compare. So I and j. And returns a Boolean value specifying whether the first value should come before the second in a sorted list. I'm just in my head, I'm trying to think of what it's doing to do that, but I guess it doesn't matter. And I said we wouldn't harp on it, so I mean, we can get it in practice, but I'm just trying to think what that iterative process looks like. But yeah, it doesn't really matter because the function's already there. Okay, so then add the following code to sort your array. So we did that. All right, so let's just run it again. So Command Shift Enter, and then we get the right answer. So it did sort this 1, 3, 40, 32, and then 1, 2, 3, 13. So we got that. And because we use the less than operator, we get ascending order. It is as they said it would be. Okay. First, you create a function called is ascending. No, wait. So we don't see this. So I'm going to skip over that because this was just showing us the longer version of what we have on screen now. Okay, so closure expression syntax. Yep. This works, but you can clean up your code. There is no need to declare a named function. You can create a closure to pass to sorted by inline. Inline meaning right here where you would normally pass a function you predefined elsewhere, but they're saying you don't have to do that. you can just do it right here inside of the sorted by, where the normally the argument would go. So it's convenient. Finding separate function outside the sorted by method. Refactoring your code. Oh no, okay, so we did that. Okay. This code is a bit cleaner and more elegant than the first version. Instead of providing a function to find everywhere in the playground, you define a closure and line in the sorted by methods argument. The closures parameter and their type are the same as before. The closures parameters and their type. All right. Try not to yawn. In the closures body, you provide the same logical test, is I less than j. Is I less than j? There we go. To determine the Boolean return value. The result is just as before. The sorted array is assigned to volunteers sorted. Yep. This refactoring is a step in the right direction, but it's still a little verbose. Oh, okay. Oh, snap. Closures can take advantage of Swift's type inference system, so you can clean up your closure even more by trimming out the type information. Oh. Yeah. I mean, you could do it. You could voluntarily make your code more vague. I'll do it, but I don't want to do it. I, J, N. Oh, that's cool. That is really convenient, and I probably would be tempted to do that only in a closure. But I think if you're gonna, I don't know. Here I go making exceptions. Whatever. Do whatever you want to do. Okay. I'm just saying. I'd like to see it because this is nice if you know what you're looking at. Otherwise, you come across this in a single line. I mean, if I saw this, I would think I was reading JavaScript. What the fuck is this? Man, that is... Dang, brother. You got it all on one line, too. Yeah, we're fighting if somebody does this. In the code base. What is this? Yeah. No, that's cool, though. Yeah. It is convenient. It's convenient. Okay, IJ in return. Yeah. Spaghetti mode. Alright, so does it work the same? It does. There are 3 new developments here. First, you remove the type information for both the parameters and the return. You remove the type. Okay, right. Yep, so the int declarations and the bool. Where do we... The compiler can infer that the parameters have the same type as the elements in the input array. Okay, meaning since we're passing it this array of integers, it can just pick it up there and know that it's also handling integers. As for the return type, the compiler knows that checking I less than j will return a true or false. Yeah. That is a bool value. Yeah. In all seriousness, I would think the return value of bool would probably be the one exception I would routinely make, because, yeah, that one I feel is not so vague, even in just reading the code. Second, you move the entire closure expression to be one line. Third, you remove the keyword return. Oh, wait. Oh, yeah, you're right. I was wondering why mine was still getting to another line. Okay, so, dang, that is pretty terse. It's kind of nice. Yeah, I don't mind it. Okay, so second, you move the entire... Okay. Notice that the result in the console has not changed. Your closure is getting fairly compact, but it can become even more succinct, really. So it provides positional variable names that you can refer to in inline closure expressions. That one popped my brain a little bit, huh? Your closure is or wait, but it can, Swift provides a positional variable. Positional variable names that you can refer to inline closure. These shorthand names behave similarly to the explicitly declared arguments that you've been using. Explicitly declared. Oh, okay. They have the same types and values. The compiler's type inference capabilities help it know the number and types of arguments your closure takes, which means it's not necessary to name them. Okay, yeah, show me that, because that sounds... Oh snap, I see a $sign. I love $sign stuff. Okay, so, alright, let's get to that. These shorthand names behave similarly to the... Oh, we read that. Where are we at? For example, the compiler knows that sorted by takes a closure. Yep. And it knows that the closure takes two parameters that are of the same type as the items in the array. Okay. You pass into the method's argument. Because the closure has two arguments whose values are compared to determine their order, you can refer to the arguments positionally using $0 for the first and $1 for the second. So kind of like your index 0, 1, 2, 3, 4, 5. Okay. From left to right, I assume. Is that the rule? Or is it based off the operator? Notice that, well, meaning whatever's on the left side of the operator would presumably be $0 always. But we'll see. That's a guess, not a statement. Because the closure has two arguments. Okay, right. Notice that the positional variable names are 0 indexed. Also, for a closure with more than two arguments, you can use 2, 3, and so on. Okay. Adjust your code to take advantage of the shorthand syntax. So what do we do? Yeah. Sorted equal. Oops. Volunteer. Oops. Man, look at that. All right, forget everything I said about types. I would definitely use this. I like that a lot. That's way, in a way, by becoming even more terse, I feel like this is, it still has that at a glance quality that I would want the code to have. Yeah, that's cool. Yeah. So, yeah, I guess the magic of type inference. Okay, so now that your inline closure expression uses the positional argument syntax, I think, well, I'm just curious. I want to go see real quick. That's basically all, like everything in Go. Like they only have positional variables. But I just want to see if it converts to the same thing that I'm kind of thinking about. Going, yeah. Oh, import. Oh, so they have a sorting module. Main function. Declare an assignment operator. Integer of arrays. Or array of integers. And then you call sort dot. Oh, interesting. Yeah. Huh. I kind of like that better, but interesting. Okay, so that's not the example I was thinking of, but yeah, this isn't half bad either. Okay, so then you know what's crazy though, real quick aside, like the difference between, like, you wouldn't know it, but I mean, these are very similar pieces of syntax, right? But a lot of people won't take the time to even go. I'm not saying this is like, oh, great job, brother, give me all the praise. No, I'm just saying most people won't even go out of their way to even go to this amount of detail. And obviously this did not take a lot of effort. I just went to a website that does it for you. But my point is, probably 85% of all the bitching and whatnot that goes on between, you know, language wars, people flaming each other on Reddit, YouTube comments under the videos, this shit sucks, you know, all that stuff. I'm not saying everything, but oftentimes the difference is about at this scale, like just small little, you know, nothing worth the amount of vitriol that it generates. So just saying that to say that you should establish your own opinions. Don't get sucked up in all that mess. Totally pointless. Okay, so and you know what also that I've really noticed just in general is so there's certainly aspects of marketing you have to watch out for, but a lot of times a lot of the big concepts you hear in programming, like polymorphism or something like that, I mean, they're not these grand concepts, and usually they're also poorly named. Like they don't really even address the concept that it's supposed to describe or embody. So yeah, just don't be afraid to dig into things. I think more often than not, if you have even a decent foundation, or even just pick up on things quick, you can understand things at the conceptual level. Nearly anything, if you just give it 30 minutes of your time to really read it and understand it. Not saying you can go out and implement it, but to understand the concept, you can, and it's a great place to start, and it's a great way to, discover new things. Okay, let me hop off the soapbox. Okay, now we're back coding. So now, where was I? Shorthand. Okay. Now that your inline closure expression uses positional argument syntax, you do not need to explicitly declare the parameters as you did for I and j. All right, yep. The compiler knows that the values in the closure's arguments are of the correct type and knows what to infer based on the less than operator. Before you think this closure could not possibly get any slimmer, wow, really? No way, brother. Just wait. There is more. Closures that appear at the end of the argument list can be written outside of and after the function's parentheses. I'm breaking my brain here, brother. This is called trailing closure syntax. If doing so would leave an empty pair of parentheses behind, you may remove them entirely. Make this change. What? I don't see the difference. Volunteer counts sorted. Oh, the by. That's not what I have. Oh, I guess Oh, I didn't do this right. So my error led to confusion. See, kid, this is why you type annotate. Never mind. I take everything I said back. Yeah. No, but also I'm dyslexic. And this font is tiny, but y'all don't need to read it because I'm reading it. And it fits on the screen. So, okay, so this is what they're talking about. Okay, I confused myself because that's what they have. So I didn't write in the parameter up here, the by : but I should have. But now they're saying we don't need it, it's optional. Okay. All right. So then here, because no parameters remain after moving the closure argument outside the parentheses, what print? Oh, okay. Okay, so same issue. I just confused myself because I didn't put these here before. Yeah, so you can just do. All right, what's already there? Okay. Okay. Here, because no parameters remain after moving the closure argument outside, the parentheses are deleted. Notice that when the closure moves outside the parentheses, its argument label is removed from the call. Is removed from the call. Oh, I see. Yeah, because it was here and then. Okay. That makes sense to me. Yep. If there are multiple trailing closures, you can have multiple. This only applies to the first. Subsequent trailing closures retain their argument labels. For example, a function whose signature looks like this. Func do awesome work on input string using transformer. Then completion. Would be called using trailing closure syntax like, well, hold on. Okay, so this could be written why is the copy so dookie on this? Okay, so print. Alright, so what is it saying? I just wanted to get the syntax down there. Okay, so notice when the closure moves outside the parentheses, argument labels removed from the call. If there are multiple trailing, this only applies to the first. Their argument labels. Oh, okay. So as a function and then as a closure. Okay. And you're saying... What are you saying? Expected... Wait, what? This is their code. So what did I miss here? Func. An input string. That's what we got. Using transformer... void, got that. Then completion, void. Oh, there's no, okay, my bad. I see. What's this error? Input. I don't know where it's from. Okay. Oh, it's probably in Foundation, I bet. But that's just an example, so they didn't. Okay, so I just wanted to see the syntax. So then let's separate it out. Do awesome work. Okay, so now that I know what I'm looking at, if there are multiple trailing closures, this only applies to the first. Yeah. In this example, the using parameter name. So here is omitted, but then is not. Truly, brevity is the soul of wit. The code in listing 13.6 works just as well in this terse form as in the earlier, much more verbose version. Yeah, this whole thing has been odd for me. It's just, that's a lot of ways to do one thing. I guess if anything, I would just rather them teach like the best practice way or whatever first, and then show me other ways how we might come across it. But I don't like it's probably my one critique. It's not a big one, but I'm just thinking out loud. I don't necessarily like the whole, let me build you up. Let's start out and do it real complicated, and then build up to whatever the standard is. But it also explains why this book is 800 pages. They're really giving you everything. So that's obviously not a bad thing from an educational perspective. So, yeah, I mean, honestly, I suppose that's better, because otherwise you go, presumably, you go off into the world thinking just the one way. And if that's what you expect and that's your only understanding, maybe it's more of a struggle for you when you go out into the wild and see all the, other types of Swift code. Okay, so I convinced myself. Never mind. So this is good. So this trailing closure syntax adds complexity to the language. Yes. But it feels more stylish to many Swift developers, as it helps remove clutter from the function call site. Yeah, I mean, yeah. I wish you could, is there not Go has a formatter. Oh, here we go. No. Does Swift Xcode have a similar to Golang's How do I run it? I'm using playgrounds. That's what I figured. Whatever. All right, that's fine. So then, this trailing closure language feels more stylish to Swift developers. Okay, and yada yada yada. Do not feel like you need to use all these code condensing features to be an effective Swift developer. They are here for your convenience. The most important thing is to make sure your code is readable and understandable as possible. Yep, I would agree with that. All right, functions as arguments. You initially sorted your volunteer counts array using a named function passed as an argument to sorted by method. Although that particular task could be accomplished elegantly without the need for a function, there are times when declaring a function and passing it as an argument to another function is the best solution. There are times when declaring a function and passing it as an argument to another function is the best solution. Right. You initially sorted. As a named function. I don't remember doing that, so let's go look, because using a named function. Oh, that's right, we did before we hit, okay. I do remember that now. Now you'll write your own function that takes a closure to modify a collection. In the playground, add this incomplete function. Okay. I think I want to get rid of all that stuff. Okay, func, format, numbers. Okay, so we're writing a function called format. First parameter name is numbers. Its type is a integer of doubles or decimal values. Using will be a external parameter name, aka an alias for the real parameter name of formatter, which will be a, what do we got here? I guess a tuple. Containing a double. And it will return a string. What, brother, you got? Okay, string. And then that returns an array of strings. String. Then we open up the body of the function var result. So a mutable variable named result equal to array of strings. Oh, so we initialize a mutable empty array that will contain strings at some point, presumably, and then return a result. Oh, it does close it. Okay, this was throwing me off the way it was formatted, but okay. That is a lot of parentheses. Yeah, it is. Do not be intimidated. You know what's funny? Look at this. I told you guys that there was an actual programming language called Clojure. You can see the difference, but Clojure. So look at this. Speaking of parentheses, isn't that weird? Like everything's in parentheses there because everything's just a function. So Clojure is interesting just because, like, I would use this language if it wasn't a JVM language. I just don't. There's two things I hate. I shouldn't say that. There's two things I will do everything in my power to not have to use two particular tools. Okay, so the first one is Python, which has nothing really to do with the language itself. It's fine. I'm not a huge fan of white space, although I used to feel a lot differently. But now that I've actually written actual programs, I can say I'm not on the white space team. The indentation over squarely brackets, although I don't necessarily enjoy brackets, but significant white space is not better. I'll say that. Now, anyway, yeah, it has nothing to do with the language itself, but the build systems and the ecosystem is just horrendous with Python. I mean, well, you guys know, anyone that's tried. It's not impossible, obviously, and there is a lot of support for it, but there's equally as much confusion and bullshit going on. It's just, yeah. Anyway, also deploying Python projects in the cloud is the stuff of nightmares. Unless you want to go use one of these massive frameworks, but then it just brings so much crap and you have so many dependencies. It's insane what they've let it turn into. But then there's also, so I mean, that for Python, that's why I don't want to work with it. For Clojure, it's the JVM. Now Java isn't nearly as bad, or rather the JVM isn't nearly as bad in terms of like installs and, you know, the ease of use, getting the whole tool chain set up, the runtime. But it is still kind of a chore. And I don't know. The idea of running on your code requiring a virtual machine to run in general is not appealing to me. It's you know, I feel like we're past that, or I would like to be. But yeah, Clojure runs on the JVM. So now there are other implementations of it, I believe. So that's not necessarily always true, but the official, I'll say the primary implementation of Clojure runs on the JVM. So yeah, but if it wasn't for that, I think it's a great language. It looks a little funky, but if you are either new to programming or functions just kind of speak to you more in general over other, and that's how I was, because they make sense to me. Yeah, I think you'll enjoy it. But yeah, it's neat. There's not a lot of syntax. You just write whatever the function is, or the operator, and then everything after that is just an argument. So function in the first position, and then everything following that are just arguments. Pretty neat. But yeah, it gets a little wild with the parentheses. So anyway, where were we? Now, modify. Okay, so we're here. Do not be intimidated. Study the function signature from beginning to end. The format number using function takes two arguments, numbers and using, and returns an array. And we know that because that's what this is here. So func keyword, we name it, and then here are the parameters. we go. There. So here are the parameters, numbers. Yep. Okay. So
I don't want to sneeze. Once you let one out, it won't stop.
Okay, the format numbers using function takes 2 arguments and returns an array of strings. Whew. The first argument is an array of doubles. Yep. The second is a closure that takes a double and returns a string. That's what's throwing me. It looks funny. So you're telling me I can have...
Oh my gosh.
Don't do it.
Okay. In other words, takes an array of numbers, closure, pass in a second.
Alright, let's read that again.
In other words,
format numbers using takes an array of numbers and a closure that can format a single number into a string. This is really throwing me. How is this? Oh, okay. Yeah, it's really throwing me off. Just because these are on separate lines there. That's better. Okay, so there we go. That was really messing with me for like 2 pages now. Okay, so the function takes 2 arguments and returns an array of strings. The first argument is an array of doubles. Yep. The second is a closure that takes a double and returns a string. In other words, format numbers using takes an array of numbers and a closure that can format a single number into a string. Yep. Okay. The specifics of the formatting will be defined by the closure that is passed into the second argument. So whatever you pass to formatter is what they're saying. It could take an array of 7-digit numbers and format them as phone numbers. Make sure that each element in an array of dollar values has exactly 2 digits after the decimal point, and so on. Make sure that each element in the array of dollar values has exactly 2 digits. Oh, I see. Okay. The next step is to apply the closure to each number in the array. Flesh out the body of the function to do exactly that. Flesh it out. It's a weird saying. So beneath my initialization of mutable variable results, which is an array of strings, so a for statement, I have a conditional for number in numbers. So number singular is my iterator that I just made up. That could be anything. In is a keyword. Numbers is our first argument in the format function, so we know that this will be an array of doubles. So that's why we can just name it here. And then we do this let transformed. So this would be one of those temporary, what do they call it? Temporary. I forget what they call it. Something along those lines. But effectively, it's a constant, but only in the context of when this function runs. Otherwise, it's not going to exist. So created and destroyed in the same, or all within the confines of executing that function. Let transformed equal formatter, which is our other second parameter using, okay, so formatter number. Oh, I see. Okay, so this works because formatter is a closure. And so in this context, it's just like as if you were calling formatter as a normal function. And you want to apply, or you want to pass your iterator to the formatter. Okay. Yeah, a lot of stuff in programming works like that, kind of like an onion, kind of like works inside out, or in the reverse of what I guess the normal way that you would think about it would be. Or maybe that's just me, but in a normal way, like that I would think about it, like when I just described it to you, we said, you know, it's the other way around, like the number, the iterator, you're formatting the numbers, basically. I guess that's not backwards, is it? Okay, fine. I disproved my own. Okay, yeah. All right, so then where's the specifics will be defined by the... Okay, so all we were doing, all right, we did that part. Formatter number and then result. So we need our results. Result dot append. Okay, so we initialize the array of strings here. We make it mutable. So in this case, result is mutable because it's a var, and we need it to be. Because here it's empty, and then after the fact, presumably it will not be. And then we say for iterator number in numbers, which numbers is an array of doubles, then format the numbers we pass in, keep that in a variable called transformed, and then on the mutable array that we initialize here, we call the append method, aka the function, and we append whatever value we have in transformed after it's been formatted. Okay. And then we return the result. So presumably we just build up that array. It all goes into result. Once it's done processing the full array, then we just return that array of strings. Okay. Return result. Sure. Return result. Yeah. Okay, now you can declare a closure that a caller of this function might provide for, now you can declare a closure that a caller of this function might provide for transforming a single double into a string. Now you can declare a closure. Okay. Pardon me. Wild night last night. Not really. Okay, recall from the beginning of this chapter that functions are closures with a slightly different syntax. Functions aren't. Right. Yeah, okay. I recall. You call a closure the same way you call a function by its name with a parenthetical argument list. It's not true. Okay, here you call the passed in formatter closure with number as its argument in formatter number, right? We talked through that. Thinking back to the volunteers example, suppose you have been asked to report the average. I have to use the rest. Hold on, just 1 second. Jared, we need to get a graphic on this, brother. I can't keep. I can't keep using the toilet. emoji, but man, it works good for now. Okay, I'll be right back. Alright, sorry, just make sure I was still swole. Okay. Alright, so now that I've addressed the issue, won't say anything beyond that. We can get back to it. Okay. Let's go ahead and take down my announcement here. How's that look? I think that's big enough, yeah. Okay, so where were we? Recall. Okay. Thinking back to the volunteers example, suppose you have been asked to report the average number of volunteers each organization sent to this year's major events. It might sound weird to say that an organization averaged 10.75 volunteers per event, so you want to round the averages to the nearest integer and drop the decimal point. Create a closure to accomplish this task. Okay. Let rounder. Okay, so what are we doing? We're declaring a constant. And its type is a closure. Well, I want to ask the Oracle something because I want to make sure my understanding is correct of the use of the parentheses. So how can I ask this? How can I know or not? Functions definition is referring to a closure versus a tuple. Actually, I think we covered. I think we said all. Or that functions use tuples. It was something along those lines. Maybe there isn't a distinction, but or not a worthwhile one. Oh man, my bad. Damn it. In SwiftUI. Okay, yeah, I'm definitely confusing myself then, because yeah, I'm getting caught up in the syntax itself, because this would be obvious to me. I mean, if I saw that, I wouldn't think, oh, that's a closure. It would be like, no, that's, yeah, it's a tuple. Because it has a string and an integer, so only tuples can do that, right? Or I think that's right. Or maybe dictionaries could too, I'm not sure, but either way, and then this is a closure. And so I was getting confused because it's saying we're gonna write it so we can pass it a closure. Oh, here's the closure. Okay. Just forget that whole thing. I just had to do that to confirm something that I can't really even articulate what I was confused about, but I think I got it. Okay, so let rounder of type double, and this is a double precision floating point. Yeah, but what is that? Is that a tuple? What is this in SwiftUI? Okay, so that is a tuple. It does seem unusual. Single element. Why not use a double? However, tuples are often used in Swift to group multiple values, and even though a single element tuple is syntactically valid, it is rarely used. As the tuple that holds one value. Values. So, other question, could okay. Okay, so it's a tuple, single element tuple. Okay. So let rounder with a type tuple return string, and that's equal to this closure. Num double. Int to convert it to an integer, num dot rounded. Dot rounded. Oh. 1, 2, 3, 4, 5. Wonder why I didn't highlight, but that should be right. Okay. Alright, so what do we do? That rounder type double tuple with a double inside. It'll return a string. So we take where's num coming from though? Where is that? I guess that's its first definition because it's a closure. Okay, so it's a single argument double, so that this here return string. Oh, so we're going to use this somewhere. Okay. I was about to say, well, what's it acting on? Okay, so then here you define a double tuple with a single element that's a double. returns a string closure that returns the string interpolation of an integer rounded from a whole number. Right, so the int converts the rounded number. So the number, and then you apply the rounding, and then you convert that to an integer because it's initially a string. Okay. To round a double to the nearest integral value, you use its rounded method, which returns another double. Makes sense. So you have a decimal value, you call the rounded method, and it returns another decimal value, but now it's been rounded. So 10.6 becomes 11.0. Oh, I can't do that. Var equal 5.5. I'm just curious what it does with the intersection. Okay, so it's still... Okay. That's typical, so that's good. Just wanted to make sure. So 0.5 or higher, you're rounding up. Otherwise, you're rounding down. Okay. Becomes 11. Finally, you interpolate the integer into a string. Remember, format numbers using. Format or closure must return an array of strings. Wait. Finally interpolate. Yeah. Remember, format numbers using. Usings. Formatter closure must return an array of strings. Okay. Now prepare your list of average volunteer counts, rounded and converted to strings. Okay. Let volunteer averages equal this big array here. 75, 4.2, 1.5, oops, 1.5, 12.12, and 16.815. Oops, 815. Let rounded average as strings. Average as strings. That's what I'd be saying. Okay, format numbers. So that's our first parameter. And we want to pass in volunteer averages. Okay. And second parameter using rounder, our closure. Okay. The values listed in the sidebar for rounded averages as strings should read 11, 4, 2, 12, and 17. Does it? Oh, this one, not that one. 11, 4, 2, yep. 12 and 17. Okay. What if the caller of your function does not want to have to provide a closure for the using argument? What if the caller, rounded average. Okay, what? So what if the caller of your function does not want to have to provide a closure for the using argument? Oh, I see here. So what if we don't want to have to do that? Is what you're saying? A reasonable default behavior for your format numbers using function would be to just convert the numbers to strings if no custom formatting is desired. I see. Update the declaration. Man, update the declaration of format numbers using. So what did you change? Freaking Texas weather just assaulting my allergies right now. Oh. Okay. Func format. Wait, what are we doing? Func format. We're changing this. Update the declaration. Func format numbers double. Oh my gosh, I don't want to sneeze. Using formatter double. Returning a string. Still got that. Double string. Equals. Damn it. Equals. Escape character. Positional variable. 0. Squiggle. And then close it up. String. Our results. Oh, do I have that backwards? Yes, I do. My bad. Okay, so that. And it's a problem now, brother. And that should return an array of strings. Wait, what do you mean? Okay, so where is the end of this? Yeah, how can I... Okay, fine, we'll break the rules here because I don't know what I did to this. Return result squiggly. Okay. I don't even think I had. I'm not sure. Doesn't matter, but okay, so now that we got the right context. So we define a function called format. And okay, so here's the end of the argument. So all of these here are its parameters. First one is an array of doubles called numbers. Next one is called formatter with an external name of using. And that is a single element tuple. The value of a double, and that should return a string. The equals thing is, I guess that's specific to closures, but okay, so we're saying the return string what was the $0 again? Oh, 0 index. So we're just returning the array. Yeah. And the return type is an array of strings. Then in the function itself, we initialize this empty array of strings called result. Okay, and then we work through that. Okay. So then that rounded using rounder, we got that part. Here you use a technique that you learned in chapter 12 to add a default value for the formatter argument. Oh, that's right, we did. Okay. It just looks different because I thought it was related to closure, but it's not, just because we're using this expression syntax. Okay. So this is just saying if not specified. So if the formatter is not specified, just use or make it equal to whatever is passed in. Which would be whatever's in numbers. No, I'm not saying that right. Okay, well, tell me. What is it saying? What is it saying? Here, use a technique you learned in chapter 12 to add a default value for the formatter argument. A concise closure that merely returns its argument interpolated into a string. That merely returns its argument interpolated into a string. Oh, okay. So it takes whatever we pass into numbers and stringifies it? Is that what you're telling me? Default. Now, if the caller does not pass format numbers using, does not pass the function a closure, the function will just use each number's description. What? Each number's description for the strings instead. What do you mean description? Verify your updated function works by adding a call that omits the using parameter. Okay. The exact average. Strings equal format numbers. Okay, so we run that. Sidebar should show the value of exact averages strings as, yeah. Okay. Oh, but it's strings, not, okay. Let's put this in the explainer. I get what it's saying, but I need to have it said again in a different way. Until it just feels like you understand, you know, it's a feeling. You either got it or you don't. And I don't feel like I got it yet. God damn, it's freezing. The provided code defines a function named, oh yeah, let's get to takes an array of double values and as an optional closure parameter formatter and an optional. The function returns an array of string values. Here's a breakdown of the code. There we go. First, func format, numbers, double. Okay, so this is a function declaration. The function takes two parameters, numbers, right? So we follow so far, and an array of double values. Formatter, a closure that takes a double. Formatter, a closure that takes a double value and returns a string. I got this on the wrong side. It has a default value of that expression, which simply converts the double value to a string using string interpolation. Okay, so that is all it's doing. So, but what is 0? Verify for me. The function returns an array of string value. Wait, double value. It has a default value of this one, which simply converts the double value to a string. Using string interpolation, the function returns an array of string values. Starts a loop, iterates over each double. Format closure. Okay. Whoa, what's all that? But okay, so I guess the distinction I'm looking for is really just if I see this in this equal sign after a type within the confines of a function's parameter listing, which is where we're at. It's a default value. And so really this, I mean, anything, since it accepts expressions, this could be anything. But in this case, it's just interpolating the string. Okay. But oh, okay. So I thought it was doing it here, but it's not. It's acting on this. Okay, so that's the part I want to hone in on, because that's really what I want the answer to, just to be sure. So I want it to tell me that $0 is referring to the single element tuple that's there. So given the SwiftLang below is the in the Swift code you provided, $0 is not referring to a tuple, double. But rather, it is shorthand for the first argument passed. Oh, okay. So the $sign refers to arguments that are passed to it, not the types. Yeah, this is really kicking my ass in terms of like recognizing the closure. I mean, I get what they are and how they work, but this putting it in the, I don't fucking know. I don't know. So, okay, so this, but rather the pass to the closure. So the first argument. I guess, so I was expecting that, I guess I just can't have it that way, but I thought I would always see it represented in the same way, but I suppose that's not true, because if you, like within the context of a single, like anywhere you would define a type, like just like you define a type here, this is a doubles, or an array of doubles. Here we're declaring formatter. So I guess if I see type and return, that's why it's a closure. So this really isn't the type, it's what's passed to the closure. But ultimately it'll be this type. Okay. That's kind of what's doing me in, but what are you doing? What are you doing to me? Okay, so yeah. The closure parameter, the closure formatter double string. So that's why I just need to open up my mind, make sure I know that this in totality is the closure, not just any one component of it. Takes a single double as an argument, right, which is here, and returns a string. Shorthand argument name. Swift allows the use of shorthand enclosures when the context is clear. Here, $0. First and only argument. Okay. Default closure value. That's a default value for the formatter. Okay. Okay. That makes sense. Hopefully that makes sense to anybody else that sees this, but yeah. That was much needed because that was really messing with me. So that represents a closure. Or rather, more specifically, this. Because were it not a closure, you would just see, you know, that or some kind of type annotation, but that's my giveaway there. So if I see a return type where there would normally just be the type, and the clue can also be, obviously there will always be one return type for the function in totality. So within the function signature, I suppose you could say, I mean, just as a rule of thumb for my use, I could say, if you see more than one, we'll just make it simple. If you see more than one arrow, which indicates a return type, if you see more than one within a function signature, which we know embodies from the name to the, basically the beginning of the function body. If I see more than one arrow, I know I'm passing a closure somewhere in there. And then obviously I would look at it and say, oh, well, here's the parameter containing the arrow syntax, so it must be formatter that I'm passing a closure to. And then I'll know that this first type here is the type for what I would pass to the closure. Okay. Where did I leave off? Default return. Now if the caller does not pass format. Yeah, I wanted to ask about that too. What does that mean? So the function will just use the numbers description. Let's see. Giving me below excerpt. Swiftline is, or so what is the definition of description as it is used here? What else do I want to know? How is it? Is that a, how do you spell that? Ascertained? Okay. So it is an actual, like, legitimate term. not necessarily specific to the book's teachings, which will be fine, but I wanted to make the distinction. So then the term description in this context refers to a textual representation of an object. A textual representation of an object. In this case, each number in the numbers array. Okay. Default closure argument. The function is defined with a default closure argument for using. Well, I guess not. I mean, we don't have to dig into it. That makes sense, because I wouldn't expect it to stringify it into anything other than what I pass to it. So if I pass it 3, I get 3 in a string. Pass it 8, I get 8 in a string. Or 5.12345, that's what I get in a string. So, okay. I just want to know if that was a legitimate thing, and it is. All right, so we'll just assign that little bit of knowledge as a thing about Swift and possibly other programming languages. We'll put it on the nice to know list. Okay. Verify that by calling. Okay, we did that and we got the 5. Yeah. Okay, so now closures capture their enclosing scope. Now that you have some experience with closures, it is time to examine an important feature. Hold on, I'm gonna stretch my legs real quick. Ooh. think I got an email here. Hold on one sec. What is this? Oh, okay. Okay, my bad. I just gotta respond to this guy real quick. Gotta keep up on your opportunities. You know what I mean? Hope you, yeah. Signature. New gate code. Just add this here. Man, I love Telegram. It's so good. Okay. All right. Where was I? Now that you have some experience with closures, it is time to examine an important feature of how they interact with the code around them. To set the stage for this examination, you will want to have a few different scopes available. Any scope will do. Conditionals, loops, and functions all define scopes. For this experiment, nest your rounder closure and its usage in the scope of a new function. Okay. Func. Format numbers. Double. Using formatter. Double. So now we know this is that's a closure. And okay, we're oh, that's bolt. Yeah, it's hard to tell. Okay. So this one. I was rewriting the old one. Func experiment with scopes. Let rounder double. Okay, so that's in the type declaration, that's our closure syntax. In return, string interpolation, and then int we call to convert it, and we call it on the rounded number. Okay, so same as last time, but now experiment with scopes. The experiment with scopes function. Wait, I did something wrong. What's the problem? Oh. Well, no, they didn't have to do that. Func. Let rounder string equal. Oh, I skipped that part entirely. Double string equal. Wait, what the jank? I gotta make this bigger. It's easier when there's like one code example per page, but now that's not working out. Okay, so what did I do? I'm adding the func after the... Okay, yeah, experiment with scopes. Yeah, let rounder return string equal. I don't know where I got in from. Or maybe this shouldn't, oh, this shouldn't be here, I don't think. Wait, what? I'm tripping out. What is it? Oh, I got this stuff in between it. Wonder why? What? Okay, now that you have some experience with code, time to examine a few different scopes available. Any scope will do. But this is the old one. Yeah, that's the old one. Okay, we're breaking all the rules today, but good grief. I might just go half screen with it, because alright. All that. And that. Okay. Rounded to let's. Let. Okay. Alright. Command Shift Enter. The experiment with scopes function provides a nested scope, so you can inspect the interactions between declarations in different scopes. Provides a nested scope. Oh, okay. All right. Now I think I see what I'm looking at. Okay, so this is the scope of some vising. This is the function scope. here's our closure. Previously defined I guess globally, is that what you would call that? Maybe. Probably. So now this would only be, or this version of it, it feels different, would only be available inside this function scope. Okay. Yeah. After defining the function, you call it so that your code will execute when the playground updates. Okay. Add a variable before your add a variable before your declaration of rounder and modify it within the closure. Okay. Experimental scopes. Var number of transformations equals 0. Okay, let rounder. Okay, that's all good. Here you set aside a variable to track the number of transformations you perform, which is equal to the number of times your closure runs. Okay, so I need to add number of transformations increment operator, increment by 1. Oh, right. Okay, so via type inference, wait, number of yeah. So this we initialize at 0, and since it's nested here in the scope of this closure, it'll increment up by 1 from 0 each time it's run. Okay. Boy, it's neat. Okay, then what do we do? Okay, that's all the same. Okay, here you set aside a variable to track the number of transformations you perform, which is equal to the number of times your closure runs. You increment that value. Increment. You increment that value each time rounder executes. Yep. So far, this does not seem far-fetched. Recall from chapter 12 that a function can use any of the variables. Where'd my gator go? Recall that from chapter 12 that a function can use any of the variables defined in the same scope it is defined in. So far, this does not seem far-fetched. Recall from chapter 12. Any of the variables defined in the same scope it is defined in. Also called its enclosing scope. Oh, yeah, sure. Okay, so it makes sense that rounder has access to number of transformations. It makes sense that rounder has access to number of oh, yeah, we get that. Okay, then reread the explanation for listing 12.9 if you need to review. I don't think we need to. So for the same reason, experiment with scopes could call format numbers using. Oh, yeah. Format numbers using. Right. Because this isn't nested anywhere, it's global. And neither is that, so it could. Okay. Well, but only because the signatures match, right? So otherwise, if we want to be really, really nerdy and anal about it, that's really why. So that plus it's allowable within the confines of the scope. Okay, so then, however, go back. However, a function cannot see into another nested scope. So for example, result, which is declared in the local scope, format numbers using, is invisible to rounder. However, a function cannot see. So for example, results. Okay, so here. And it's inside the scope. And they're saying it's invisible to rounder. Rounder being here, which, yeah, I mean, that makes good sense. They're obviously not in the same scope. Okay, so then a function or variable that is declared outside any other scope. Outside any other scope. Okay, so there's that semantic meaning. Is considered to be in the global scope. Okay. And it is visible to any function or closure in the program. Any of them. At all. Get some nice little circular references going. In the example above, format numbers using and experiment with scopes are declared in the global scope, but number of transformations in rounder are in the local scope of experiment with scopes. Yep. Now print the value of number of transformations after format numbers using is called with rounder as its closure argument. With rounder as its closure. Okay. So let exact averages. Where you at? Down the print number of transformations. 5. Why is it 5? Oh, there's 5 elements in the array. 5 times. Because you got to transform the entire array. So 1, 2, 3, 4, 5. Okay. Hot dog. Alright. The value printed to the console should be 5. The format numbers using function executed the rounder closure 5 times, 1 for each number in volunteer averages. And each time rounder incremented the value of number of transformations. This means that rounder has access to number of transformations even when it is passed to format numbers using. I get the whole scope thing, so I'm not going to get stuck on their way of explaining it. So I'm just going to keep reading until I see it not working that way with the syntax, because I hope everyone is following. Yeah, because it's a lot of explanation for something that I think is basic, but there's other things that I don't even know, and someone else might feel the same way. So I guess that's why there's so much around this, but it seems pretty, the whole scope thing seems pretty, it's very algebra like, if you learned, paid attention in math class to any degree, this probably makes sense. The whole scoping, parentheses, working inside out, that kind of thing. Okay, in fact, we say that a function not only has access to, in fact, we say that a function not only has access to its enclosing scope, but also captures it. We say that a function not only has access to its enclosing scope, but also captures it. When you define a function and then pass that function as an argument, it maintains its access to the variables that were in its enclosing scope when it was... Oh, yeah, sure. I got you, brother. So you're saying that, since I'm passing rounder into other functions, it's inheritance, basically. It's inheriting anything you define in that scope. So if I go past this function that contains any of these variables, then the function that I pass it into would also have access to these same variables, which makes sense because it still follows the whole scoping mechanisms. It would be inside the parentheses passed as an argument, so it makes sense. So okay, so that's what they mean by capture. It not only so access to its enclosing scope, meaning the squigglies when you define it, and then the capture verb is meant to represent that inheritance aspect. Yeah. Okay. When you define a function and then pass that function as an argument, it maintains its access to the variables that were in its enclosing scope when it was defined. In this example, when the closure stored in rounder, in this example, when the closure stored in rounder is passed into format numbers using, where it becomes the local variable named formatter. It is no longer in a scope that can access number of transformations. The formatter closure can only access number of transformations because the closure captured its enclosing scope when it was defined. In experiment with scopes. Okay, so in this example, when the closure stored in rounder, is passed into format numbers using, so here's the closure, and then we pass that in for the value formatter. Okay. The formatter closure can only access number of transformations because the closure captured its enclosing scope when it was defined. The formatter closure can only access number of transformations because the closure captured its enclosing scope when it was defined. I don't get how I don't get how they're tying the two together, so we'll just keep going. I get what it's saying again, but still. Print. I mean, I get what it's saying now. I mean, because it's talking about this. Because we have it in two places. But here it's inside the scope of this function. In the enclosing scope. But in this example, when the closure is stored in rounder, this one, it's passed into format numbers using, which is up here. So when it's passed in as the formatter, follow that. And they're saying it becomes the local variable named formatter. Local as in local to this function's scope. It is no longer in a scope that can access number of transformations. Oh, okay. Now I get it. Okay. Yeah, okay. So this gets passed in to formatter, and when it does, it becomes a local variable here, but it's inside this scope, and inside this scope the number of transformations variable we created is not defined, and so it's saying it no longer has access. Yeah, the formatter closure can only access number of transformations because the closure captured its enclosing scope when it was defined. So it's contrasting the two. Okay. That's what I thought it was trying to do. I just wasn't following the visuals, but now I see. Okay, so then it's saying because this, like we said, is inside the scope here. All right. You will see other ways a closure's capture of its scope can impact your program when you learn about memory management in chapter 24. That'll be fun. Yeah, I'm really curious about Swift's memory model. there's so many, there's just a lot of conflicting what do you call them, anecdotes out there. Okay, now that you are done with your experiment, you can eliminate the experiment with scopes, function scope, and unindent its body. Okay, you just want me to... Oh, I didn't delete it. Okay. Yeah, get rid of that, right? Yep. Get rid of that. Get rid of the caller and the closer there. Oh, unindent its body. Xcode will select the code. Oh man, it was Control I this whole time. Control I. Control I. Bullshit. Come on, man. How do you do... Even that doesn't work. Bro. Is it Control? Oh shit. Control Shift. That's what it was. Never mind. That's not what I wanted to do. That's what I wanted to do. What is the problem? Type expression is ambiguous without... Okay. Oh, I already have... Yeah, why do I have it twice? Format. Averages, rounded, exact. Oh, that's where my function was, yeah. I'm surprised they didn't tell me to clean that up, that's all. That or maybe I probably did. Maybe I just added that and wasn't supposed to, or shit, I don't know. Volunteer averages. And I got that twice. I don't know, really. As long as it's working. It's not. What's the problem now? Encountered a crash. Well. Why? What is it? But I still get my array, my sorted array down here. Format, numbers, volunteer averages, using rounder. I don't think it does, but does it matter if... It's still doing that. It's weird that the error is here. But it's still able to be used. I think it froze actually. It's not really doing anything. Okay, now it is. Okay, so we're good there. Does this run? No error. Okay. Good old Xcode. Okay then. Functional programming. Damn, how long is this chapter? Higher. Oh, no. Okay, so we probably should wrap it there because, yeah. I mean, this is making sense to me, but I can already tell. I mean, I'm gonna get boned hard on the, pardon my French, on the challenges. It's just a lot. It's a lot of information. Hopefully you're picking up what I'm putting down because, yeah. But it's going to be a struggle. It's going to be a struggle. This stuff is pretty new to me too, obviously. Well, I mean, specifically some of these concepts, because again, with what I've used before, you know, there was SQL, which is very declarative in nature and not nearly as, I mean, it's, you know, you're talking to a database, so there's very, like a big part of that is just knowing the schema itself, which is going to be implementation specific. Just kind of depends on what you're working on. But I mean, SQL unto itself can get very complex, but you know, it's not in totality. If you're just querying data, doing select statements, it's pretty straightforward. And it writes very much like the English language. So there's literally, it's like select, and then you put your fields that you want, and then from, and then you name your table, and then where, and then you add your conditions, or there's case statements, and then you can do joins, but you know, a lot of that, it's just very straightforward, you know, powerful but straightforward for the most part, at least on the querying side. really it's the DBA stuff, like at scale, that can get pretty complex, and you need to understand how to manage your logs more than anything effectively. You know, being comfortable with disaster recovery. I had to go through that just one time, and it was very stressful, but it wasn't our data, it was for a customer. I had to rebuild their database. That was pretty, it was cool. It was intense, but it was pretty cool experience, only because it ended with, you know, a big win. At least we got to look like the good guys. Their IT had fucked up their backups, and they basically got to a point where they were going to have to, for about, I think their calculation was for about the next 4 months, they were going to have to pay overtime to have people come in, and, you know, because they lost, that's how much data that they'd lost, because the server went down, didn't have the right backups, yada yada. And yeah, they were going to, using their paper logs, because luckily they kept paper copies. They're a spice producer. They make all kinds of different, like, pre-packaged proprietary spice blends for other food manufacturers. So just like literally like giant 40-pound bags of spices. But you know, it's a lot of data entry, because it's a lot of different ingredients. And they were using our system to do that. But, you know, it doesn't matter what system you use if you don't have a good backup plan. If whoever's managing your data, your in this case it was SQL Server, so just, you know, whoever's managing your back files, shit, man, make sure you have some way, either pay somebody to do it or read a book, learn it yourself, at least to some basic degree, and make sure they're actually doing it, because yeah, that was crazy. But yeah, they're gonna have to pay people to come in and dig up all the old paper logs that they kept and just re-enter data into the system. And so I was able to repair their database. So that was a good feeling, you know. But my point is that that's a very, like, crucial core skill that is complex, and you should practice at it, because it's, you know, you don't want to, that's one of those things where you don't want to be in a situation where your first real world application of it is a real world scenario. But yeah, so there was SQL, and then Golang. Golang's pretty simple as well. I mean, obviously it can do anything that Swift can do. It's just, you know, it doesn't have the ergonomics that Swift has. But I think now I'm starting to see the other side of things, just in terms of, like, it's different when it's one thing to wax philosophical about it, like, oh, should languages have, you know, is there such thing as too many features, versus, you know, just keeping it simple, like Go, and only having more or less one way to do things. That's not completely entirely true of Go either. But yeah, it's just interesting to, because even with Go, I guess maybe that's a testament to how simple it is, or how approachable it is. I don't know that I would call it simple, but it's approachable for sure. I didn't learn it the same way that I'm doing this style with you guys. It was more like, you know, the typical traditional Google snippets of code, and just kind of hack it together, and when you hit a wall, go learn more, and come back, and then, you know, hit a wall, go back, learn more. That kind of very build it as you go kind of thing. So I didn't want to do that. I mean, for this, since I'm in a blessed situation, I have the time to do it. So I really wanted to treat Swift differently, in the sense that I want to learn it at a deep level. Hence the, you know, 800-page book, and the style is lent towards that, because it's obviously showing us, like, literally every single kind of way it might be written. So but yeah, it just, these are just observations. I'm just filling time till Jared gives me the thumbs up that we can yep, we're good. Okay. Yeah, so yeah, we're gonna wrap it up there. pick it up here, page 277. So thanks for struggling with me today. We'll be back tomorrow. I think, so tomorrow, let's see. Let me make sure my schedule, because give you a little update here. Let me see. Yeah, tomorrow. Okay, so tomorrow, Friday, I have an interview, my third and final interview for this director of BI delivery position. It's for a local firm here in Dallas. Already met the guy. I mean, it's like almost a custom fit for what I was doing before. So I'm pretty sure I'm gonna get it. But I have that presentation in the morning. Just have to do a short presentation to the owner and some of his chosen minions, and then they'll make a decision. But yeah, I'm feeling pretty confident because we already talked about like start date and all that stuff. So yeah, but we'll see. Never know. But either way, my point in saying all that was that even if I do get that job, or no, I shouldn't even say that, but it doesn't matter. I'm going to get it. But yeah, on the 27th is when I would start. And I think May 27th, which is, what's today? Yeah, so that's potentially 20. My math is terrible. 25 more sessions of this between now and then. Even if I went pessimistic and said, okay, maybe I'll miss 5 days, that's 20 sessions. So at this rate of progress, yeah, we'll probably be done. Well, at least with this book. So I don't know, I'm just thinking out loud here, but I need to, maybe when we get halfway, I should start planning out what the SwiftUI component will look like. I'm just kind of waiting to see. I know they broach the topic in this book. I don't know how deep it goes, but if not, I'll have something ready. There's another, actually, yeah, okay, never mind. I did buy a SwiftUI specific course also. So yeah, never mind. I do have something in the bag already. Yeah, so we will do that. So it won't be, the SwiftUI portion won't be Big Nerd Ranch, but we'll come back to Big Nerd Ranch after SwiftUI to dive deep into iOS. So by that point, then I'll probably have started my job. But I say all that to say the time for these Swift Learnalongs likely will not change. But once we get over into iOS, I'll just tell you guys the new time, you know. But yeah, just FYI, so you can adjust your life and schedule to my stream. You know, it seems sensible. Okay, so then aside from that, guys, make sure you check in tonight for the Halo stream. We've been slapping cheeks lately, but still Platinum 3 because they reset the season. So Jared, next time we need to sync up on those on the season instead of doing the 100 days. We probably should have thought about that, but that's okay. It's still fun. It's a lot of fun, actually. I mean, it's a lot more fun when you don't suck, and I'm getting better now. You know, so it's very much like programming. It's a lot more fun when you don't suck. So we just got to grind till we get there. Thanks for tuning in, y'all. We'll see you tomorrow. Peace and love. Don't forget to follow, donate, wire transfer, Bitcoin, Dogecoin, Patreon, money order, pocket change. Good day to you.